Good morning Year 8 and welcome to today's maths lesson. Here's the starter for today. Can you solve 4x is equal to negative 16? Can you find the area of this rectangle and can you find the area of this triangle for me? Pause the video and have a go at those questions in your light blue books now. Right, let's go through the answers. To solve an equation I want x on its own. So Eva, what do I need to divide both sides of my equation by this time? Divide by 4, very wise Eva, which gives me x is equal to negative 4. For the second question I asked you to find the area of this rectangle. Area of a rectangle is just length times height. 5 times 2 gives me 10 centimetres squared. And for the area of a triangle we needed to do half base times height, which is half. My base was 5, my height was 2, so we should have got 5 centimetres squared, because this triangle is just half of the rectangle above. Right, Year 8, dark blue books out for me. Can you write the title area of a triangle? And underneath, who can remind me what's the formula for the area of a triangle, please, Vicky? Great, it's half times base times height, or we can write that as half BH. I'm going to go through an example and then you're going to do an example. So pens down, eyes on me while I go through the first one. To find the area of this red triangle, I need to do half times base times height. This time my base is 12. My height is 4. 12 times 4 gives me 48 times a half gives me 24 centimetres squared. Hopefully this is all revision from Year 7. Over to you, Year 8. Can you now have a go at the your turn question at the bottom in your dark blue books? You've been given lots of information about your triangle. Please make sure you use the correct information to work out the area. Right, let's go through the answer. So the area of this one, in the same way, is half times base times height. This time my base is 12. But is my height 8, 6 or 3.5? James Cork, which of those numbers is my height? 3.5, exactly. We need to look at our perpendicular height of our triangle. So I've got 12 times half times 3.5, which gives me 21 centimetres squared. It's an area, so we measure it in centimetres squared. Over to you, Year 8. In your light blue books, A, B, C or D, which of the following triangles does not have the same area? And the correct answer is D. They all have the same area. The answer is 15 centimetres squared. They all have exactly the same area, despite the fact they are all different shapes. And again, the area of this triangle is 60 millimetres squared. Can you calculate the length of the missing side? Pause the video and answer this question in your light blue books now, please. Right, let's go through the answer. So the area of the triangle is given by half times base times height. This time we're trying to work out what the base is, but we know what the area is. The area is 60. So 60 is equal to half. I'm just going to put the height first. Half times 12 times the base. Half of 12 is 6, so 60 is equal to 6 times whatever the base is. Dividing both sides by 2, the base is equal to 10. Now look at your units. The area is measured in millimetres squared, the height's been given in millimetres, so your base is 10 millimetres. 10 millimeters is equal to 1 centimeter. So the correct answer was A, 1 centimeter. Okay, Year 8, in your light blue books, please pause the video for 10 minutes or so and have a go at these questions. If you're less confident, start on the red, slightly more confident, start on the yellow, and super confident, start on the green, working backwards to find a missing length. Pause the video and complete those questions now, please. And these are the answers I was looking for. Please check your work and see how you did. Right, let's talk about prisms. I've given you an example of a prism and a non-example of a prism. What do you reckon a prism's got to have in order to be a prism? What's the difference between these two examples? Pause the video, have a little think. Okay, Sophie, what do you reckon a prism's got to have? It's got to have a flat face. The example of a cube's got flat faces, whereas the sphere hasn't got any flat faces. So to be a prism, must have a flat face. Here's an example of a prism, and here's a non-example of a prism. This one's not a prism. What do you reckon a prism's got to have? Pause the video, have a little think for me. Okay, Libby, what do you think a prism's got to have? A prism has got to have the same cross-sectional area all the way through. If I slice the cuboid anywhere along this length, the cross-sectional area will always look the same. It will always look like a rectangle. However, if I slice this pyramid, my cross-sectional area is going to change. If I slice it this way, it's going to get bigger and bigger and bigger. If I slice it this way, it's going to get bigger and smaller. It's got a different cross-sectional area on its way through. How about now? What do you reckon's got to be true about a prism? Again, this proves that it needs to have the same cross-sectional area all the way through. The triangular prism has got the same triangle all the way through if I sliced it, whereas this weird looking shape has a different cross-sectional area as I sliced it through. Let's think back to our cuboids. We worked out the volume of a cuboid as length times width times height. What can you tell me about the width times the height, Jonas? It's a flat face, and this width times height is equal to the cross-sectional area. If I sliced that cuboid anywhere along, my cross-sectional area would always be equal to the width times the height. So, a cuboid is just a special type of prism. So if the volume of a cuboid was given by length times width times height, and we said that this bit here was just equal to the area at the front, what do you reckon the volume of a triangular prism might be? Pause the video, have a little think. So the volume of a triangular prism is just the cross-sectional area times the length. All you'd need to do is work out what the area of this bit is this time and multiply it by the length. In the same way as when we had the cuboids, we just worked out what the area of this bit was and multiplied that by the length. Okay, Year 8, dark blue books out for me. Can you write the title Volume of a Triangular Prism? And underneath, can you write Volume of Prism equals cross-sectional area times length? Then pens down, eyes on me. I'll go through an example and then you're going to do an example. So this is why we revised the area of a triangle. It was to help us out with these types of question. The first thing I need to do to work out the volume is work out the cross-sectional area. My cross-sectional area is the area of this triangle on the front. We know the area is equal to half base times height. For this triangle, that's half times 3 times 8, which gives me 12 centimetres squared. Our volume is given by the cross-sectional area multiplied by the length. So our volume is just 12 multiplied by the length, which in this case is 4. So our volume is 48. And Ollie, what do I need to write on the end of my answer? Centimetres cubed, exactly. Don't forget your units, Year 8. Over to you in your dark blue books. Can you have a go at this example for me? Pause the video and complete that now. Rightio, let's go through it. This time the cross-sectional area is equal to half the base, which is 6, and the height, which is 8. 6 eighths of 48 divided by 2 gives me 24. To work out the volume, I then need to multiply that by the length. 24 multiplied by 4 gives you what, Lily May? Great, 96 centimetres cubed. Please make sure you've got this example in your dark blue books for me, Year 8. Okay, pause the video for me and calculate the volume of this prism. Is it A, is it B, is it C, or is it D? Pause the video and complete that now. Right, let's go through the answer. The volume is going to be equal to the cross-sectional area times the length. This time, my cross-sectional area is a triangle. So my area is half base times height, which is half times, here's my base, 8, times my height, it needs to be my perpendicular height, which is 3. So my area is 12. To get my volume, I just need to multiply that by the length. So I get 12 times 12, which is D, 144 centimetres cubed. Over to you, Year 8. In your light blue books, please pause the video for 10 to 15 minutes. Can you work out the volumes of these triangular prisms? And if you're confident, have a go at my extension question. You may use a calculator if you're working on the extension question. Pause the video and complete that now, please. And these are the answers. Please check your work and see how you did. If you did my extension question, well done. These are the answers I was looking for. Okay, one final type of question I'd like to go through. So in your dark blue books, we're going to continue underneath our title, Volume of a Triangular. Only this time, we want to find a missing length. Pens down, eyes on me. I'll go through an example and then I'll give you one to do. To start off with, I've been told the volume of this triangular prism is 240 inches cubed. I know that the volume is given by the cross-sectional area times the length. Only this time, my cross-sectional area is a triangle. And we know area of a triangle is half times base times height. So I know my volume is half times base times height. This bit's the area. Multiplied by the length. Let's substitute in all the values I've been given. I know volume is 240. Half is just a number. We're trying to work out what the base is. We know what the height is. The height is 5. And we know what the length is. The length is 8. So 240 is equal to half times 5 times 8. 5 times 8 is 40, divided by 2 is 20. So 240 is equal to 20 times whatever my base might be. So to work out what my base is, I need to divide 240 by 20. 240 divided by 20 gives me 12. So my base must be 12 inches. Correct. Over to you, Year 8. In your dark blue books, have a go at this example in exactly the same way. Remember, your volume is your cross-sectional area times the length. In this case, your cross-sectional area is a triangle, so you can substitute in half times base times height. Pause the video and have a go at that now, please. Right, let's pop in all the values we know. We know the volume is 135. Half is just a number. We're trying to work out the base. We don't know what that is. The height is 5. And the length is 9. This time we know that 135 is equal to half times 5 times 9. 5 times 9 gives me what, Jonas? 45, exactly. Divided by 2 is 22.5. Divide both sides by 22.5. Could have used a calculator at this point if you wanted to. The base is equal to 6 centimetres. Ta-da! Please make sure you've got this example written in your dark blue books. And then, can you pause the video for me, Year 8, and have a go at these examples for me? Can you find the missing length? The ones where you're missing the length work in exactly the same way. You've just been given the other two values. Pause the video for 10 minutes and complete those questions now, please. And these are the answers. Please check your work and see how you did. And that's the end of today's lesson. Please head over to Google Classroom and submit today's exit ticket. Thanks for listening, Year 8, and have a wonderful day. Goodbye.